How plate tectonics shapes mineral deposits. Plate tectonics plays a critical role in shaping mineral deposits by driving the geological processes that concentrate valuable elements into economically significant quantities. The movement of tectonic plates creates dynamic environments where minerals are formed, transported, and deposited. These processes occur over millions of years and result in diverse types of mineral deposits, each associated with specific tectonic settings. Here's how plate tectonics influences mineral formation. 1. Divergent plate boundaries. At divergent boundaries, where plates are moving apart, new crust is formed as magma rises from the mantle. These settings, such as mid-ocean ridges and continental rift zones, are significant for the formation of certain mineral deposits. Massive sulfide deposits. Hydrothermal activity at mid-ocean ridges generates massive sulfide deposits rich in copper, zinc, gold, and silver. As seawater circulates through hot volcanic rocks, it dissolves metals, which are then precipitated when the fluid cools. Magmatic deposits. The crystallization of magma in rift zones can lead to the formation of chromite, platinum group elements, and other valuable minerals. 2. Convergent plate boundaries. Convergent boundaries, where plates collide, are among the most important tectonic settings for mineral formation. Subduction zones, in particular, are hotspots for the creation of mineral deposits due to the intense heat, pressure, and magmatic activity. Porphyry copper and gold deposits. These form in volcanic arcs above subduction zones, where magmas enriched with metals rise and cool, depositing copper, gold, and molybdenum. Epithermal gold and silver deposits. Hydrothermal fluids circulating in volcanic arcs deposit gold and silver in veins near the surface. Orogenic gold deposits. In regions of mountain building, orogeny, gold is concentrated in quartz veins formed by high-pressure, low-temperature conditions during crustal deformation. Base metal deposits. Zinc, lead, and other base metals often accumulate in sedimentary basins adjacent to subduction zones. 3. Transform boundaries. At transform boundaries, where plates slide past one another, the friction and localized deformation can create pathways for mineral-rich fluids to circulate. Gold and base metal veins. Transform faults can serve as conduits for hydrothermal fluids, depositing gold and other metals in fault zones. 4. Intraplate settings. Mineral deposits are also associated with intraplate tectonic processes, such as hotspot activity and mantle plumes. Diamond deposits, kimberlite pipes, which bring diamonds from deep within the mantle, are often associated with intraplate volcanic activity. Nickel and platinum deposits, large igneous provinces, lips, formed by mantle plumes, can host deposits of nickel, platinum, and chromium. 5. Sedimentary processes linked to tectonics. Tectonic activity influences sedimentary environments where minerals can accumulate. Placer deposits, gold, diamonds, and other heavy minerals are concentrated in riverbeds and beaches due to erosion and sedimentation in tectonically active regions. Evaporites. The formation of evaporite minerals like gypsum and halite occurs in tectonically controlled basins where restricted water bodies evaporate. Banded iron formations. BAF's ancient tectonic settings contributed to the oxygenation of Earth's atmosphere, leading to the precipitation of iron-rich minerals in shallow seas. 6. Continental collision and metamorphism. During continental collisions, rocks are subjected to extreme heat and pressure, leading to the metamorphism of existing mineral deposits or the creation of new ones. Metamorphic deposits, graphite, garnet, and kyanite often form in collision zones. Hydrothermal veins, deformation and fracturing during collisions provide pathways for mineral-rich fluids to deposit metals in veins. 7. Plate tectonics and supercontinent cycles. The assembly and breakup of supercontinents, such as Pangaea, drive long-term tectonic cycles that influence mineral deposition. These cycles create diverse geological environments, including rift zones, collision zones, and sedimentary basins, where minerals accumulate. Conclusion. Plate tectonics is the engine that powers the Earth's mineral cycles. By creating conditions for magma generation, hydrothermal activity, sedimentation, and metamorphism, tectonic processes shape the distribution of mineral resources. Understanding these relationships is crucial for mineral exploration, as the tectonic setting of a region often provides clues about its potential for hosting valuable mineral deposits.